We're going to go over congruent triangle notes. The first thing we're going to talk about are congruent polygons. So any shapes that happen to be congruent. What does that mean? That means that all parts of one polygon are congruent to the corresponding parts of another polygon. Corresponding angles. That means that all angles are in the same relative position on two polygons. And lastly, corresponding sides. That means that all sides are in the same relative position on two polygons. All right, we're going to practice that here. So we have corresponding angles. So we denote congruent angles with these arcs. So this angle B is going to be the same as this angle J because they both have one arc. So angle B is congruent to angle J. And those would be my pink ones. And then the two arcs are A and K. So A is congruent to K. And then lastly is C is congruent to H because they have three arcs. So that's how you figure out the congruent angles. Sides are shown with tick marks. So AB right here has one tick mark, and that is going to be congruent to KJ because it also has one tick mark. So AB is congruent to KJ. And then the next one is BC. It has two tick marks. That one would be congruent to HJ because it has two tick marks. And then lastly would be AC, which has three tick marks. That one would be congruent to HK. That also has three tick marks. All right, and then we can state the triangle congruent statements. So it doesn't matter how you name the first one. I'm going to name it ABC because it's just alphabetical order. So how you name the second one depends on the first one. So what I mean by that is A is my blue angle, B is my pink angle, and C is my green angle. So whenever I name the second one, it has to go blue, pink, green as well. So that would be K, J, H. So they have to be in the same order with their congruent pieces. All right, we have the third angle theorem, and all that says is if two angles of one triangle are congruent to two angles of another triangle, okay, so what that means is what's shown on this picture. This angle is congruent to this one, and this one is congruent to this one. So if you know that two sets of angles from one triangle are congruent to two sets of angles of the other triangle, then the third angles are also congruent. So that would mean that A, and yes, it needs 3 because we don't know if it's the same as the other two, would be congruent to L. You can assume that because the other two are congruent. All right, then we have practice problems. And on these, we're just going to state all the congruent angles, all the congruent sides, and then the congruent statement, which just means the congruence of the two triangles themselves. So we have one arc, which is angle C on this first triangle, to one arc, which is angle B on the second one. So angle C is congruent to angle B. And then we have angle B on the first triangle is congruent to angle C of the second one. And then angle A, which has 3 arcs, is congruent to angle D, which has 3 arcs. Now we need to do the sides. So we have on the left triangle, this would actually be a little bit easier if I separated them. So I have this triangle here that's ABC, right? And then I have this one over here that's BDC. Both of these have one tick mark, but on this picture, they share the same line. They are still separate sides on each triangle, but they are congruent to each other. However, the way you name them is going to be different because this is our side, right? So let me highlight these to kind of explain. So this one on the left one was blue and this bottom one was pink. But on the right one, the B is pink and the C is blue. So for my first one, if I name it BC, then it would be congruent to not BC, but to CB. Because the C and the B's are blue separately, and then C and B's are pink separately. So it just has to do with the markings that are on that picture. Then we have AB, which has 2 tick marks, would be congruent to CD, which has 2 tick marks. And then the last one is AC, which has 3, is congruent to BD, which also has 3. And then lastly, we state the triangle. So if I name my first triangle ABC, my second triangle, I went ABC, right? So I went up, which means on this side I have to go up. So it'd be DCB. All right, for number 2, we have 2 sets of parallel lines, which means that we end up with parallel lines cut by a transversal. So that tells us about some angles, right? So, and then these are also parallel lines cut by that same transversal. So this angle here and this angle here would be congruent because they are alternate interior angles. Same thing with this angle here and this angle here because they are alternate interior angles. And then the last angle of both triangles, because we know those two are congruent, these would also be congruent because of the third angle theorem. So we know they're congruent. All right, let me get rid of all these extra lines now that I've explained it. Okay, so all of the angles. Angle J is congruent to angle L. And then HIJK. I like to go in alphabetical order. I don't know why. It's an OCD problem. I'm sorry. Angle K is going to be congruent to angle M on the second one. And then lastly, angle M on the left one would be congruent to angle K on the right one. All right, so now sides. JK has 2 tick marks, and that would be congruent with LM, which has 2 tick marks. KM here, excuse my dog, I am so sorry. So this one would, because it's shared for both triangle, we know it's the exact same length, no matter which triangle it's on, because they share it. So we are going to have to call it different things. So I can call it KM for my left bottom triangle, but I would have to call it MK for my bottom right. And because K on this triangle is blue, we have to start with blue here, which is M. So that's why that happens. And then we have JM, which is 1 tick mark, being congruent to KL, which has 1. So JM is congruent to KL. That's a terrible congruent symbol. There we go. All right, so whenever I name my triangles, they have to match. So if I name my first one JKM, it would have to be congruent to JKM is counting this way, LMK. All right, so those are my congruent triangles with all of the symbols available. On this one, it's super easy because it tells you what all is congruent to what. So A is congruent to D because they are the very first letters. So that means that if A is 45, D is also 45. And then B is congruent to F. So B here is congruent to F here. Those would be the same. We would set them equal to solve. And then lastly, angle C is congruent to angle E. So these triangles are oriented the same, but if they weren't, it would be very easy to figure out what is congruent to what because they tell you the names. It makes life so much easier when they give you the name of the triangles to begin with. So let's solve for y. We can set these two blues equal to each other. 8y minus 5 is equal to 99. Add 5 to both sides, and that's 104. Divide by 8 on both sides, and y is 13. So now we can deal with these. Let's say they weren't oriented the same. How do you know what side goes with what? So this side is between blue and green, so you would have to go to the other side that's between blue and green. That's the way that works if they weren't oriented the same. What I mean by that is like these aren't oriented the same. So sometimes they won't be. And that's how you figure it out is the blue to green side has to go with the other blue to green side. So 2y plus x is equal to 38.4, but that is 2 times 13 plus x is equal to 38.4. 2 times 13 is 26. So let's flip this around just because it's the way we typically write stuff. Subtract 26 on both sides, and you have 12.4. All right, on this one, we're going to have to go with marking, so it's not as easy. It's not bad, but it's not as easy. So this one arc here, which is that measure, goes with one arc over here. The double arc here goes with this double arc over here. And then the last angle, using the third angle theorem, these would have to be congruent as well. Okay, now, good news is we can figure out what blue is because they give us all of the angles on this one, so we just subtract them from 180. So 180 minus the pink 148 minus the green 18, and that leaves us with 14 degrees for blue. So now I can set these up. They are two systems, but it's not too terribly bad. So we have 3x plus y is equal to 14. Those are our blue systems. Here, I'll highlight them so that you can remember. It's our blue angles. And then we have 5x minus y is equal to 18. Those are our green angles. Now, this is a system because it has x and y in both. But luckily, our y's are already opposites of each other, so we can go ahead and add these together, and y will go away. So 5x plus 3x is 8x. 1y plus a negative 1y is 0y. And then 14 plus 18 is 32. That means that x is 4. So to solve for y, you pick one. It does not matter which one. I usually prefer the addition one just because addition is usually easier than subtraction. So I'm going to do 3 times 4 plus y is equal to 14. You could still do this with the green one if you want. You will get the exact same answer. It doesn't matter. So 4 times 3 is 12. I'm going to write it as y plus 12 just because it looks nicer. Subtract 12 on both sides, and y is 2. And that's it for today.